This is Mr. Beck Does Your Homework. This is physics homework number 19, question number 13. A particle with charge 9 microcoulombs is located on the x-axis at the point 8 centimeters. So there's my first one, 9 microcoulombs. A second particle with charge 8 microcoulombs is placed on the x-axis at negative 6 centimeters. So here I've got 8 microcoulombs at negative 6 centimeters. What is the magnitude of the total electrostatic force on a third particle with the charge negative 6 microcoulombs placed on the x-axis at 2 centimeters? Now, this problem has a couple of things going interesting for it. So the first thing is these are all centimeters. I'm looking for the force on this charge in the middle. Now, my arrangement is that this one, the first one, is a positive charge. The one in the middle is a negative charge, and the third one is a positive charge. So what I've got is 3 charges, and I want to know what's happening to the one in the middle. Well, this positive one is going to attract the negative this way. This positive one is going to attract the negative this way. So depending upon the magnitudes of these, they might cancel out a bunch, they might cancel out a little bit, they might cancel out a lot. If this force were bigger than this force, my resulting force would be to the right. If this force were bigger than that one, my resulting force would be to the left. I'm going to be looking for the magnitude, so I won't care much about left and right, but I know that this one and this one will partially cancel out, so I'm going to subtract the magnitudes of those two. If you instead had a positive and a negative, and you were looking for the magnitude of the force on the one in the middle, well, this positive and this positive will repel, this negative and this positive will attract. So if they're both pointing in the same direction, you're going to add the magnitudes. You're going to absolute value them and add them because they're both pointing in the same direction. The same thing if you wound up having a negative and a positive. Well, the negative and the negative would repel. The positive and the negative would attract. That would pull these both to the right, so you would get a bigger magnitude by adding them both together. So I'm going to stick with mine up here. But either way, I'm going to need to know the force between these two. And then I'm going to need to know the force between these two, and then I'm going to have to figure out what to do with those two magnitudes. So that's the first interesting thing. The second interesting thing is that I've got microcoulombs, which are times 10 to the minus 6th, and I've got centimeters here. And each one of these is going to have an r, which is the distance between them. So let me look at first the force between these two. So I'm going to call that the force of charge 1 on charge 2. So this is charge 1, this is charge 2, this is charge 3 for me. Okay? So this is going to be number 1, this is going to be number 2, this is going to be number 3. So the force of 1 on 2 is going to be K Q1 Q2 over R squared. So that's going to be K, which is 8.9875 times 10 to the 9th, times the amount of the first charge. Well, that's 8 times 10 to the minus 6th coulombs. The second charge is this one in the middle, which is going to be minus 6 times 10 to the minus 6th, divided by, my r is going to be from negative 6 to 2. That's 2.468 centimeters. So that's going to be 0.08 squared. So from negative 6 to 2 is a total of 8 centimeters squared. When I do all of this, I'm going to get the force between 1 and 2. I'm going to wind up with a negative number, but I don't care. I just want to know the magnitude of that. So that is going to give me some number, and I know that that one is pointing to the left. My second force is going to be the force between particle 3 and particle 2, and that's going to give me K Q1 Q2 over R squared. That's going to give me 8.9875 times 10 to the 9th times my first charge, Q3 Q2. So let me make this Q3 Q2. Q3 is 9 microcoulombs. So that's 9 times 10 to the minus 6th coulombs. Q2 is negative 6 microcoulombs. So that's negative 6 times 10 to the minus 6th coulombs. Divided by R squared. Well, what's R for these two? I got 2.468. So I got 2.46 centimeters between them. 6 centimeters between them is 0.06 squared. Don't forget the squared. So that is going to give me the force between 3 and 2. Giving me this number. Again, this is going to give me a negative. At this point, I don't care. That means that it is attracted to the other one. But this force, I know, since it's attracted to the other one, this force is going to be to the right. So I've got this number and this number. I want to find the difference between them to find my net force. So for me, since they're pointing in opposite directions, I'm going to take the absolute value of the first force, and I'm going to subtract the absolute value of the second force. And I'm going to get some number. Now it says the magnitude, so I don't even care if this is positive or negative. Oh, you can't see that. So my net force is going to be this one and the difference between these two. So absolute value them and difference them. And then whatever this thing is, find the whole absolute value of the whole darn thing. And that is going to give you some positive net force. Now remember, if your two are pointing in the same direction, you're just going to add the magnitudes right here and here. If they're pointed in the same direction, you're going to add the magnitudes. So pay attention to that, be ready to draw a picture and see which way the forces go.